Okay, so here we are, 1.3. Number 1, so they're giving me a point negative 6, 8. It's the terminal side, I'll explain that. Find the exact value of the 6 trig functions. Exact value of the 6 trig functions. Okay, so let's do that. So they're saying you've got a point on the coordinate system. Let's find it. Back 6, 1, 2, 3, 4, 5, 6. Up 8, 1, 2, 3, 4, 5, 6, 7, 8. So back 6, up 8. You got a dot there. Here's the angle. Theta, I don't even know what that angle is. Who cares? We just got to find right there the sine of that. Okay. So you're with me so far. So we're going back 6, up 8. So I just took, this is the x, y coordinates of a point. It's back 6, up 8. And there's the angle theta to that location. And by the way, why did I make the angle theta here instead of down here? Remember, we always start from here. This is always 0 degrees. This is always where we start our angles. The positive x-axis. So starting from there, going to the back 6, up 8 line. You with me? So this dot here is back 6, up 8. So from 0 degrees to that, that's the angle theta they're talking about. They're asking me for all 6 trig functions. They want the sine of that angle, cosine, tangent, all the rest. So how do I do that? Well, what you do is you turn that thing into a triangle. This is up 8. This is back 6, up 8. Turn it into a right triangle. I just brought that line straight down to make it into a right triangle. And then you move this angle theta right there. That is called a reference angle. We'll get more into that later. I'll give you more official definitions and stuff. For now, let me just say, it's always the angle to the x-axis. It's the angle to the x-axis. In other words, it's not this one. Because this one hits the x-axis. You with me?
Can you say that again?
So whenever you put the angle theta in your triangle, always put it with the one hitting the x-axis, not the other one. So it's a reference angle, which means hits the x-axis. Later I'll tell you, because if I was you, I'd be like, well, why? Why not the y-axis? And there's good reasons, but we'll unfold the story a little bit at a time. So I'll give you some good reasons for this. I don't want you to think math is like magic. I hate teaching that way or appearing to teach that way, because that would not be very helpful to you at all. Math is got reasons for everything. It's logic. It's just logic unfolded. And I want you to see the reasons, but I can't do everything at once. So I'll slowly unfold the reasons. For now, let's just say you always put that angle theta to the x-axis. So I took it from out here, which might seem kind of weird. It was out here, and all of a sudden it's right there. I mean, isn't that smaller than that? It is. There's good reasons. For now, I'll just say that's always what you do. You just stick that angle in there, inside the little triangle to the x-axis. Okay, so what? Well, now I can find all the answers they want. Like I can find the sine of theta. Well, how do you find the sine? Well, SOHCAHTOA, remember? So what is sine? Opposite over hypotenuse, right? It says right here, sine is opposite over hypotenuse. So look at this angle theta. Who's the side opposite this angle theta? Who's opposite? 8. The 8. Over the hypotenuse. Well, that's here. I don't know. I'm going to have to do some work with the Pythagorean theorem to find that hypotenuse, and then I can finish answering my questions. You with me? So let's stop what we're doing, do the Pythagorean real quick. Hey, does anybody know the answer already?
10.
Yeah, how do you know?
Because it's 36 plus 64 and then square root of that.
Okay, you're just doing the whole thing in your head. Did you know it's 3, 4, 5 doubled? It's good to memorize a couple of Pythagorean triples. Pythagorean triples, I mean like 3 squared plus 4 squared is 5 squared. It's a very commonly used one, right? Because that's 9 plus 16 is 25. That works, right? So 3, 4, 5 is a common, very common Pythagorean triple. This is 3, 4, 5 just doubled. If you double 3, you get 6. Double 4, you get 8. Double 5, you get 10. It's 3, 4, 5 doubled. So when you see 6, 8, you should think, oh, they're doing the 3, 4, 5 trick. They're going to do this a zillion's not a number, but a lot of times in our class, probably 100 times is not an exaggeration. You'll have 100 homework times when they use a variation of 3, 4, 5. So if you just want to save time, when you see something like 3, 4, 5 doubled or tripled or whatever, it's go, oh, there it is doubling 3, 4, 5. So that's 3, 4, 5, 6, 8, 10. That other side's got to be 10. But anyway, I'll go through the formalities. I'll do it just to save you time. So you just say, okay, 6 squared plus 8 squared, right? 6 squared plus 8 squared is going to be this other side right here. Call it c squared. Oops, I'm in the wrong thing there. C squared. So what is that? 36 plus 64 is c squared. That's 100 is c squared. Root it. Sure enough, there it is. C is 10. As we know. They're playing the 3, 4, 5 game. Yeah.
Negative 6.
Oh, yeah, you're right, but negative 6 squared is still 36.
Oh,
Yeah. No, good. You're right, though. It is negative 6, but squared is still positive 36. So I was just kind of ignoring it, but good point. Good. We good there? So it's 10. Okay, so coming back over here now, so what's the sign? Opposite over hypotenuse. Opposite is the plus 8. The hypotenuse is the 10. And so reduce that fraction 4/5. Good so far? Now, what's the cosine?
Negative 6 over 10.
Good. Yeah, cosine SOHCAHTOA is adjacent over hypotenuse, right? The CAH, C-A-H, SOHCAHTOA, remember? So cosine's adjacent over hypotenuse. So from this angle theta, the adjacent side's the negative 6, isn't it? Negative 6 over 10. Reduce that fraction. Negative 3/5. Good so far. And then tangent. Yeah, TOA. Tangent is opposite over adjacent. So 8 over negative 6. Oops. So that's negative 4/3. It doesn't matter where the negative is, right? You guys good with that from your algebra days? Negative in the bottom, negative in the front. It's all the same thing. Multiple choice test next week. You know, if you have it negative in the bottom, the answer C or whatever has it in the front, grab it. That's the same thing, right? Doesn't matter where that negative is on a fraction. All right, and then the other 3 trig functions, they're just upside down. Can we just do that real quick? Right? I'll just do them right here. What's the upside down of sine? It's cosecant. You can write those in your 3x5 card. So that's just going to be upside down of sine. It's going to be 5/4. Upside down of cosine is secant. So that would be this one upside down, so minus 5/3. Same sign, just upside down. And opposite of tangent, cotangent, upside down, negative 3/4. Just flip it, right? For those other 3. There we go. So what did we do? So they gave me this point, back 6, up 8, put my dot down, make my right triangle, put theta to the x-axis. Not up there, but the one on the x-axis, right? This angle theta is hitting the x-axis. That's called a reference angle. So then you just do the SOHCAHTOA. Oh, actually, I had to do the Pythagorean first, and then you just do SOHCAHTOA for all the trig functions. Let's see. Okay. So yeah, so try that one. So they're given 9, negative 6. So do the same thing. Draw yourself a little coordinate system. Find the point 9, negative 6. Let me let you start. Be better than me just whipping it out. So draw that. Start. You're going to have to do the Pythagorean thing to find the hypotenuse. Doing okay? I'll jump in. Okay, so you draw your axis system. This one is going to be over 9 down 6, so over 9 down 6. So over 9 down 6. Draw your triangle. Where do you put the angle theta? Right here, hitting the x-axis, not down there, right? You with me? So everybody good so far? So you go over 9 down 6. Here's the dot. Over 9. This is over 9 down 6, right? And you put your angle theta hitting the x-axis. Not down here, because that doesn't hit the x-axis. Right? It's called a reference angle. I'll explain why later. So there you go. So now, we need this side. Do the Pythagorean. A squared plus b squared equals c squared, right? Find that side, and then do the SOHCAHTOA to find all the angles. I mean all the trig functions. So the Pythag, a squared plus b squared is c squared. So 9 squared plus negative, so it is 81 plus 36. 117, yeah, 117. So it's the square root of 117. Are we good there? So C is the square root of 117. Oh, does it simplify nice? I didn't even think.
3 to the square root of 13. Yeah.
Really? Okay, I didn't even think about that. So factor it down. It's 3 times 3 and 39. Oh, you're right. And then 3 times 13. So there's a couple of 3's in there. So it's 3 root 13.
That's what I like about this calculator right here.
Yeah, what do you got? You got the Casio natural display. I know, it's beautiful. I could be a salesman for this company. Some of my other students think I am. It is nice. I own 3 of them myself. I'm really not a salesman. But they just did a good job on this thing. The Casio, I mean, I wouldn't go out and buy it if you already got one. But if you want to get a calculator and you don't have one, yeah, it's the same price and it's nice. It's just very user friendly. Like he was just saying, it just does that automatically for you. It does a lot of things automatically. Casio natural display. Anyway, Target, Walmart, or the Mr. Heron account. No, I'm kidding. I have no interest in that company. They just did a good job in that calculator. Yeah. So anyway, yeah. So you guys, you remember this from algebra? You just divide it by 3. Remember, yeah, by the way, you know that 3 goes in, I should have recognized because the digits add up to be 9. You know if the digits 7 plus 1 plus 1, that's 9. If the digits add up to be something divisible by 3 or 9, then the entire number is. I don't know if you know that rule. Anyway, just use your calculator. Divide by 3, and you go, oh, 2 3's. So in other words, 2 3's in, 1 3 out. Remember that? It's 2 for 1. That's what square roots do. Remember that from algebra? So 2 3's inside the root. In other words, the root of 117 is root of 3 times 3 times 13. 2 3's in sends 1 3 out. Right? That's what square roots always do. They do 2 for 1, don't they? Right? What am I talking about? Well, what's the square root of 9? 3. What just happened? There were 2 3's in there. Now there's 1 out. That's what square roots always do, don't they? There are 2. I tell my algebra students there are 2 for 1 sale at Target. That's what square roots do, right? 2 3's in, 1 3 out. So 3 root 13. All right, good. Thanks. I didn't notice that. So now take it from there. Let's do the SOHCAHTOA thing. SOHCAHTOA. So the sine of that angle theta. I don't even know what the angle theta is. I don't care. But the sine of that angle is opposite over hypotenuse. So which side is opposite from this angle's perspective? Yeah, this is opposite. Over hypotenuse, over 3 root 13. Now, they're not going to let me leave a square root in the bottom. First off, let's cancel 3 into 6, huh? 2. So let's just do that first off. Minus 2 over root 3. And I still can't leave it that way. Everybody good so far? I'm just doing a sine, which is opposite over hypotenuse. Opposite over hypotenuse. 3 went into 6 2 times. Now I can't leave roots on the bottom. You know what to do. Multiply top and bottom by square root 13. Remember that from algebra? The bottom, it becomes a plane 13, right? Because 2 13's in, 1 13 out on the bottom. There's the sine. Is that good? And then cosine, same thing, opposite, not opposite. Cosine is adjacent over hypotenuse. So that's what? Adjacent is the 9, right? This is the adjacent side. This is the opposite side, and this is the hypotenuse. Are you guys comfortable with that, right? See this angle theta here? This angle theta? Both these two sides hit angle theta, but this one's hypotenuse. So this is the adjacent. It just means next to it. And this is the opposite. Okay. So adjacent over hypotenuse, and so that's 9 over 3 root 13. So 9 over 3 root 13. We cannot leave. 3 goes into 9 3 times, so we get what? 3 over root 13. Can't leave the root 13 in the bottom. Multiply top and bottom by root 13. I'm running out of room here. So we're going to get 3 root 13 over plane 13. And there we go. I don't feel like doing the rest. You good with the rest? Tangent, then flip them for the other 3. You good? By the way, I wouldn't flip the, let me flip one of them. To do cosecant, for example, flip it back where it was easier. To do cosecant, which is the flip of sine, right? It's 1 over sine. I wouldn't grab the final answer and flip it, because then you're going to have a root on the bottom. You have to deal with that again. Grab it back when the root was on the top. On the bottom, and then it'll be on the top. Just flip this version of it, right? And you go straight to your answer. Minus root 13 over 2. Boom. See what I'm saying, guys? To save you some time and effort. Don't flip the final answer, because that root 13 is going to go to the bottom, and then you're going to have to do another step. Just do it right here before you got rid of the root from the bottom, because then when you flip it, it just goes to the top. All right, enough said. I'm going to move on from that. If you're good, questions on that? Is that okay? Let's be on YouTube later. Now, you could just use your calculator. Sine 3 pi over 2. Yeah. Why shouldn't we just use our calculator right now? Yeah, let's just use a calculator. So what do? You plug in pi is 180 degrees, right? So it's the sine of 3 times 180 over 2, which is the sine of 270, which your calculator will tell you is negative 1. Everybody good with that? Or you could have just left your calculator in radian mode and type that in as a radian angle. Either way you want. Negative 1. That good? I flash that off. Just put in 180. That's converted to degrees, and hit the buttons on the calculator. Or you could have done it from radians in the beginning. All right, try that one. 10 to the power 2. Tell me what your calculator says. Answer is getting an error, undefined or error, right? You guys getting the error in your calculator? That's correct. You should be getting an error on your calculator, which means the expression is undefined. We'll talk more about it a little bit later. Just want to make sure you're able to get that in your calculator at least, though. Is that good? Undefined? Getting that answer? Yeah, so pi is 180. So you should get tangent of 180 over 2, which is tan of 90, which should be error or undefined on your calculator. Right? That coming out? If you're having trouble, grab me afterwards. Calculator stuff. I can help you. 10 seconds. Get you.
90, it does the error, but when I type in tangent power over 2, it gives me like 0.0247.
Tangent power. Do you have it on your screen right now?
Let me make sure I have it right.
Yeah, it's probably that. Pi over 2, you'd have to be in radian mode,
Okay, that.
because that wouldn't be a degree. Yeah, so if you want to type in tangent pi over 2, see, that's radian, so be in radian mode. If you want to change to 90 degrees, make sure you're in degree mode. It'll work either way. Either way should be. So we're going to start getting us more comfortable with where these things sit. Okay, cosines. Okay. All right, I'm going to give you, before we get too tricky with it all, I'm going to give you the positive negative rule for sine, cosine, tangent. Anybody know it already? There's some little saying. I don't think it's very popular anymore. It used to be more popular in my day. All students, you seen this? Take calculus. That's true, right? You guys gonna take calculus? I hope. All students take calculus. All students take calculus. So that's a memory device for helping you remember the signs. What does that mean? All, meaning all 6 trig functions are positive here. Sine is positive. Cosine is positive. Tangent is positive. And the other 3, which are just the upside down of those 3, cosecant is positive, secant is positive, cotan is positive. They're all 6 positive in the first quadrant. In the second quadrant, S. What do you think S stands for? I mean, it stands for students, but what trig function does it stand for? Sine, right? It's saying that sine, only sine, and of course his upside down. What's his upside down? Cosecant. Only they're positive. The other 4 are all negative. Cosine, tangent, and their upside downs, secant and cotan. Right? Anybody's upside down is going to be the same sign, right? As they are. So that's it saying in the second quadrant, only the S, only sine, and of course his upside down, cosecant. Only those 2 are positive. The other 4 are negative. In the third quadrant, down here, what do you think T stand? What trig function does T stand for? Tangent. Only tangent is positive and his upside down. The other 4 are negative, meaning sine is negative, cosine is negative, and cosecant is negative, and secant is negative. You guys with me? See, this is a way to remember which functions are positive where. For the 6 trig functions, this is a way to remember which 6 trig functions, which ones are positive where. All students take calculus. All of them are positive in the first quadrant. Only sine and his upside down are positive in the second. Only tangent and his upside down, cotangent, are positive in the third. The other 4 are negative. And finally, what do you think the C stands for? Cosine. Only cosine is positive. And of course his upside down, secant. The other 4 are negative. Sine and tangent are negative. They're upside downs, of course. There we go. There's how, it's an easy way to memorize the signs of the 6 trig functions in the various quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Does that make sense? So all 6 trig functions are positive in quadrant 1. Only sine and his upside down in quadrant 2. Only tangent and his upside down in 3. Only cosine and his upside down in 4. The other 4 functions in those quadrants are negative. Okay, so when they come back over here and they say, all right, cosine is greater than 0. Greater than 0. Is that positive or negative? Cosine's positive. So right away I think cosine positive. Which quadrant is cosine positive in? I haven't even looked at the second fact yet. Where's cosine positive?
4.
Well, 4th, and they're all positive in the first. So it's either 4th or 1st. I'm already down to just those 2. You with me? Cosine's positive. Cosine and all are positive. So it's one of those 2. Those are the only 2 places cosine's positive. Right? And then they tell me, what do they say about tangent? Tangent, wherever you're at, that the tangent there is less than 0. What does less than 0 mean? Negative. Tangent's negative. Well, that means they're not all positive, because tangent ain't positive. So we're in quadrant 4. Does that make sense? We know what quadrant we're in by the all students take calculus. If tangent was positive, I would know we were in the first quadrant, because they're all positive in the first quadrant, right? All right, you got all that copied down? So tangent of theta is less than 0. Cosine of theta is less than 0. So they're saying tangent is negative and cosine is negative. Do the all students take calculus thing. So see if you can figure out where that's at. You can do this one by process of elimination, really, huh? Are we in the first quadrant where they're all positive? Well, certainly not, because both these guys are negative. They're not positive, right? So we're not in quadrant 1. Let me just write the 1, 2, 3, 4. Could we be in quadrant 3 where tangent is positive? No way. Tangent's negative. Could we be in quadrant 4 where cosine's positive? No way. Cosine's negative. So we're not in 1, we're not in 3, we're not in 4. We're in quadrant 2. Make sense? All students take calculus. That's where they're positive. All are positive in the first quadrant. Sine is positive here. Tangent is positive here. Cosine is positive there. All right. All right. So we are doing good stuff here. So this is good. So this is 1.3. So sine theta is 4/5. Yeah. So here we are to the big time. We've only got 10 minutes left. This problem will probably take us all 10 minutes. This is a big one and a very, very important one. This is going to be a big thing that we do. So let me do it real slow with you and thorough. Hope you're still, is my voice still coming across? Am I doing the Charlie Brown, the 1-1-1? Has that begun for you? So dial in with me. If you've been thinking about the weekend, we got a lot of days to go. Don't think about the weekend yet. Right? Dial in with me. Make sure you're hearing this. This is probably the most important problem we're doing all day, all 2 hours here. Let's do this one well. So I'm going to draw a coordinate system. They're saying the sine of theta is 4/5. The sine of theta is 4/5, and I'm in quadrant 2. Sine of theta is 4/5. I'm in quadrant 2. So what I'm going to do is I'm going to draw a triangle in quadrant 2. Right? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. You with me? So I went ahead and, because they said we're in quadrant 2, I'm going to draw a triangle. It's centered at the origin. All the triangles we draw are always going to be centered at the origin. Where am I going to put the theta? Do you think I'll put the theta up here? Always put the thetas by the x-axis. It's called a reference angle. Haven't given you any good reasons for that yet, but I will later. That's what we always do. There's some reasons. So you put that angle theta there by the x-axis. Then you say, all right, so that's what they're talking about. And they're saying the sine of theta is 4/5. Well, what do we know about sine? We know SOHCAHTOA. That's the definition of what sine really is, and cosine really is, and tangent really is. So sine is really opposite over hypotenuse. So looking at that little right triangle, which side is the opposite? Well, it's this one. And which side's the hypotenuse? It's really that one. You with me? Opposite and hypotenuse. 4 and 5 there. Right? Okay. Well, call this x. I need to find, you really need all 3 sides of the triangle to get the trig functions, you know. So before I can go on, I really need to find that x on the bottom there. Yeah, you recognize it? There's the second time. We'll keep track. There's going to be at least 100 times. No, I'm going to lose track. But there's the second time, 3, 4, 5. That's a 3. Now you could do, if you're not sure, if you forget the 3, 4, 5, you could just do the Pythagorean thing. The a squared plus b squared is 2 squared. You'll find that it's 3, right? You just say x squared plus 4 squared is 5 squared, right? And you'll find that it's really 3. Plus 16 is 25, subtract 16. X squared is 9. You see, there it is. Sure enough, no surprise, x is 3. So I'm helping you avoid all that work. 3, 4, 5. So let me put it in there. Put it in the 3. Get rid of these little quadrant things. Put in the 3. But here's the trick, guys. Is it positive 3 or negative 3? Is it? It's back 3. This is up 4, right? You're back 3 up. Now, how do I know up, down? Well, you know the positive y-axis, negative y-axis, positive x-axis, negative x. So if you're going back, that's negative. If you're going up, that's positive. And we always just leave the hypotenuse as positive because they're a distance. So, you tracking with me? So the signs matter. Well, you know, you could, if you want to just ignore the signs and then just make sure it's right in the end with the all students take calculus, that'll work too. So either way. All right, so we're ready to go now. Let's find the cosine of theta. What's cosine? Cosine is adjacent over hypotenuse. The ca, adjacent over hypotenuse. So here's the angle theta. Which side is adjacent to him? What are the sides next to him? What are his neighbor sides? Well, these two are right next to him. This is the hypotenuse. So the negative 3 must be the adjacent. This is the hypotenuse here. So it's negative 3 over 5. You with me? Tangent. Tangent is TOA, opposite over adjacent. So that'd be 4 over negative 3. It's the opposite, right? And then the other 3 trig functions, just flip them, flip them, flip them, right? So that would be cosecant is upside down 5/4. Secant is upside down minus 5/3. Tangent upside down negative 3/4. And there we go. That wasn't too bad. We can get another one done. That's great. I never underestimate how long I'm going to take something. That was a rare moment for me. Let's do some more. So is that good to there? Question?
Why is it a negative 3?
Yeah, good question. It's because it's back 3. So if the triangle was over here to the right, it would be right 3. Yeah, so we are remembering. Oh, yeah, and what I was saying, yeah, let me show you. I'm glad you brought that up. Let me also, so for some people just think, my own daughters, when I taught my daughters through trig a year ago, or year and a half. Anyway, they just like, Dad, I don't want to fool with all those sides. I'm just going to do the all students take calculus. That's great. That works. If you want to just say, look, I don't care. I'm just going to make them all positive, 3, 4, 5. And then when I'm done, I'll just go, look, I know all students take calculus. They loved the all students take calculus thing. And they would just go, okay, it's in the second quadrant. The only ones that are positive are sine and his upside down. So sine and his upside down. They're the only positive ones. The other 4, sure enough, look at them. They're all negative, aren't they? Whoops, I put 2 negatives here. You can just do that. You know, you can just fix it later if you want. I mean, it's the same either way. You can either know it's really back 3 and then they will come out that way, or just ignore the signs and fix it at the end with the all students take calculus. It'll work either way. Whatever you prefer. Let's do this one. Now, these are really important to do these kind. Okay, so they're telling me tangent. Can y'all read that? I can write a little bigger for you. So they're saying tangent of theta is minus 3/5, and cosine of theta is greater than 0. Notice the problem. I need to know which quadrant we're in, because I got to know what the signs are going to be with the all students take calculus thing. So first order of business, before you do anything else, figure out which quadrant that's in. When they say cosine theta is greater than 0, what does that mean? Greater than 0. Is that positive or negative? Positive. So all students take calculus. Where are we? Here we are, where cosine is positive. Right? That makes sense. Quadrant 4. Right? Quadrant 1, 2, 3. So we're in quadrant 4. So when you draw your picture, put your triangle down here. Here's your right angle. There's your theta. We're in quadrant 4. Aren't we? Not good? Because cosine is positive. Remember, all students take calculus. Those are the ones that are positive. Cosine is positive down here. And they're not all positive because tangent's negative. So we're not in the first quadrant. Right? Because they have to all be positive in the first quadrant. And tangent is not positive. So we're not in the first, we're in the fourth. So do that, all right? So then take it from there now. So you can just forget about that cosine. That's all we needed for that 4. Just forget about it now. That's done. Did I erase that too quick? Sorry. Take it from there. So do the 3/5. Yeah, they're not doing 3, 4, 5 this time. They're trying to trick you. Yeah, let me do this one with you. So what's tangent again? The SOHCAHTOA thing. SOHCAHTOA. Tangent is opposite over adjacent. So this side is opposite. This is hypotenuse, of course, and this is adjacent, right? Because it's right next to the theta. So the opposite is the 3, and the adjacent is the 5. Right? This is not going to be 3. You might think, yeah, it's 3, 5. Well, no, this can't be 4. Why can't that be 4? It's the longest side. So it's not. It's 3, 5, something bigger. It's not, right? Because this is the longest side. Hypotenuse is the longest side, always. So it can't be 4. It can't be smaller than 5. Right? So this is not 3, 4, 5. Well, how do you find it? You just do the Pythagorean. Just call it X. Call it C. Call it Joe. Whatever you want to call it. And then do the a squared plus b squared is c squared. Right? So a squared. It doesn't. The a and the b doesn't matter what order. You put 5, 3, 3, 5, whatever. Who cares? Just as long as you get the c on the right side. Good. You guys with me? Got a minute and a half. We can finish this. Please finish one of the functions. That'll be good enough. 25 plus 9, c squared. So that 34 is c squared. Good to there. And then root it, right? So it's root 30. And that doesn't simplify. Just leave it root 34. That one doesn't clean up. Root 34. Good to there. Now, technically, this is a plus 5 and a minus 3, right? Because you're over 5, down 3. But like I said, if you want to just ignore those signs and fix them in the end with all students take calculus, that's fine too. Either way. Put the signs in now or put them in later with all students take calculus. It doesn't matter. So now we can find the other trig functions. We're out of time, so I'm not going to do any more. So that we didn't quite... So all let's do then, let's be clear, 1.2 only. I think Math Excel said they're both due. I'll change that. 1.2 only is due on Wednesday at 9 a.m. Just 1.2. We'll keep working on the others. Everybody got a schedule, right? Those new schedules I passed out. Everybody get one. If you missed it, come on up. I got a bunch of them here. Or no, maybe I didn't. Where are they? I don't think I got them back. Was there extra ones? Yeah, would you mind bringing them forward? Thanks.